Hey guys, I am happy to announce my brand new plugin, Infinite Scripter. And let me now show you some things that this plugin is capable of doing. In the first part of this video, we're going to be going into depth into how this plugin works, but this is not required in order to use the plugin. So if you want to, you can skip to the presets section of this video. Once you've installed the plugin, inside of the plugins tab, you'll see a new button called Infinite Scripter, and by pressing this button, it will open the Infinite Scripter window. We can press this button at the top right to open the drop-down menu, and this allows us to open the presets window, the map window, and the spline window. I'm going to be covering the map and spline window in more detail later on in this video, so for now I'm going to close these two windows. It's possible to dock these windows wherever you like, so I'm going to place these two windows over here like this. What this plugin essentially does is allows you to select a location within Explorer and then run any module within that location. So what I can do in Replicated First, create a folder and then select this folder, and we can now see that this folder has been selected. I can deselect by selecting an empty location in the Explorer and press select, and now it's been unselected. Any location can be selected. For instance, I can select the workspace and select, and here we can see the workspace has been selected. So let's select the folder once again. And inside of this folder, I'm going to create a module script, and we can see that the module script automatically loaded into the plugin. I can duplicate this module script. You can see that both module scripts are now loaded into the plugin. I can rename the module scripts. and this change gets reflected in the plugin. And if I make an error in one of the module scripts preventing the plugin from being able to load the module script, we can see that it indicates an error with this red icon. I can click on the item in the list, fix the error, and go back, and we can now see that the error has gone away. Let's now add some print statements to our module script. So I'm going to click on module script 1, and inside of this module, I'm going to simply print 1. Now, as soon as I click away from this module script, the plugin is going to detect that I've made a change to this module script and automatically reload it. So it should instantly print the value 1. So as soon as I click away, we can see it printed the value 1. And let's now add a print to module script 2. So the same way we did to module script 1, I'm going to add a print, and we're going to print the number 2. And as soon as I click away, we can see that it printed instantly. And if I now select something else, so if I select the workspace, we can see that the 2 modules are removed. And if I select the folder once again, we can see that the 2 modules were selected again, and they print 1 and 2 once again. So I can keep deselecting and reselecting to reload the modules. Let's now make the run button do something. So currently, if I turn run on and turn run off, nothing happens and nothing gets printed. So when you turn run on, the plugin will call a function in every module if that function is found, and that function is called initialize. So if we create a function called initialize, and this function is going to receive 2 values. One is the instance that's selected, so it's going to return this folder that we've selected into the function, and it's also going to give us a list of all the modules inside of this selected instance. So inside of this function, I'm going to create a print, and I'm going to print initialize. I'm going to say initialize number 1, and I'm going to pass the instance and the modules into the print like so. If I now press the run button again, we can see that nothing happened and initialize was not printed. And the reason for this is because if you remember from before, we must select something else for the plugin to detect the script change. So I'm going to press baseplate, and we can see that it printed 1. That means it reloaded the plugin. And now if I press the run button, we can see it says initialize, and it gives us the folder, which is this folder here that's been selected. And it also gives us a list of all the modules. So here we can see we have 2 modules, and inside of this module we have the initialize function, and inside of this module there is nothing, it's an empty table. If I now select replicated first and press the select button, we can see that now replicated first has been selected. And if I turn run off and then run on again, we can now see that the initialize function has passed the replicated first instead of passing the folder. And we still have access to the 2 modules in the modules table. Let's now copy this initialize function into module script 2. So I'm going to copy this here. And if I click away, we can see that module script 2 was reloaded and was initialized, but we can see it says initialize 1. So let's change that to initialize 2. And if I click away again, we can see it was reloaded again. And this time it printed initialize 2. And I can change the selection back to the folder and turn run off, clear the output, turn run on again, and we can see that initialize 1 and 2 were both called and both have access to the modules. There are 2 rules that we must follow within our module scripts. The first rule is we cannot use the global variable script. So if I print script.parent and click away, we can see that it prints Infinite Scripter, which is a folder that's part of the plugin and has nothing to do with our own project. So we cannot use script, and that's the reason why I've passed the instance into the initialize function so that we can get the ancestor of the module. And the second rule is we cannot require other modules within our module. So let me first comment out these prints so we don't get too confused. And then inside of replicated storage, I'm going to create a module script. And inside of this module script, I'm going to create a function. And this function is just going to print test1. So now inside of module script 1, inside of the initialize function, I'm going to go local m equals require game.replicatedStorage.module script, and then I'm going to call the function, and that's going to call this function and make it print test1. So let's run, and we can see that it printed test1. Now if I go to this module that we created in replicated storage and change it to test2, and if I stop and run again, we can see it still prints test1. So any changes I make in this module will not update ever again until we close Studio and reopen Studio from scratch, because this module is now cached in memory, and when we require a module, it will continue to use the cached version and not reload the updated version. So that's the reason why I pass the modules into the initialize function so that we can access the other modules without the need to require them. So let me show you how to access the modules from the modules table. So first thing I'm going to do is get this function and move it into module script 2, which is this script here. And then I'm going to delete this module script inside of replicated storage. And now inside of module script 1, we can access this function inside of module script 2 by doing, let's first delete this, and I'm going to say local m equals, and I'm going to go modules, and this requires the instance that we want. So I'm going to say instance dot module script 2, like so. So this is how we can access that module, this module here, and get access to the function, this function here. So if I now stop the game and run, you can see it's printed test2. And if I change this to test4 and stop and run, we can see it updated and printed test4. And if I print test5, stop and run, we can see it prints test5. So now this module will always be up to date when accessing other modules. So now let's simplify the project, and then I'll show you the next function that the plugin calls. So I'm first going to delete module script 2, and I'm going to rename module script 1 to be module script. I'm then going to print loaded, and I'm also going to print initialize, and I'm going to delete this part here. And now let's create the second function that the plugin calls, and that is called deinitialize. And inside of this function, I'm going to print just the same way I printed inside of initialize, but I'm going to print deinitialize. So now we have a single module that prints loaded, initialize, and deinitialize. So let's first click away to load the module, and we can see it printed loaded. And now I can run to initialize, and when I stop running, it deinitializes. And if I run again, initialize, deinitialize. And I can keep initializing and deinitializing by turning run on and off. Now what I want to do is when the module is initialized, create a folder and place it inside of the workspace, and when it's deinitialized, to destroy the folder. So at the top, I'm going to make a new variable, and then I'm going to say folder equals instance new folder, and I'm going to parent the folder, and inside of deinitialize, I'm going to destroy the folder. So now I'm going to click away to load the module, and then I'm going to press run, and we'll see the folder was created and it was initialized. And when I turn run off, the folder was destroyed and it was deinitialized. Now let me show you the last two functions the module calls. So the next function is load. And this will pass the instance, just like initialize and deinitialize, and the modules. But on top of that, it will tell you the X and Z chunk. And there's also another function, which is the exact same as load, and it's called unload. And it passes the same instance, module, and X and Z chunk. Let's now print inside of these functions. So I'm going to copy this print and paste it into the two new functions. And I'm going to rename this to load and this to unload. And I'm also going to, instead of printing the instance and modules, let's print the chunk coordinates. So let's print in the X and Z value. And let's now click away to load the module. And if I run, it initializes. And now the plugin is telling me to load all these chunks at these coordinates, which is around my camera's focus position. And here we can see that the last chunk it told me to load was at position 0, -17. And if I turn run off, we deinitialize. Now, instead of just printing the chunk position, let's create a part and position it at the chunk's position. So I'm going to say local part equals instance dot new part, and now I'm going to anchor the part. So part dot anchored equals true. Now let's calculate the chunk's world position using the chunk's X and Z coordinates. So by default, the plugin will have a chunk size of 64 by 64 studs. And later on in the video, I'll show you how to change that. But for now, let's just create a variable called size equals 64. And let's now position the part. So part.position equals vector3.new. And we can do X multiplied by size. And this is going to give us the left position of the chunk. So to get the center, we're going to add 50% of the size, so size divided by 2, and this is going to give us the center of the chunk. And for the y-axis, I'm just going to set it to 0, and for the z-axis, I'm going to do the exact same as we did for x, but replace x with z. And finally, let's set the part's parent, and I'm going to set it to the folder that we created inside of initialize. So part.parent equals folder. And so that we don't flood the output with prints, I'm going to delete the load print. And let's now test this new load function. So I'm going to go back to baseplate, and we can see that the module was loaded. And when I turn run on, we can now see that parts are getting spawned around my camera's focus position. And if I zoom out, we should see a circle of parts around the focus position. And if I keep scrolling to the right, we can see that new parts get loaded in. And once we get to a certain distance, the plugin is going to start telling us to unload parts. But if we look, because we have not done our unload function yet, the parts still remain inside of this folder. But as soon as we turn run off and deinitialize the module, this folder gets destroyed, and so does all the parts that we spawned into the workspace. Let's now set this part's size. So I'm going to say part.size equals vector3 new, and we're going to use the chunk size. So size, and I want a height of 1, and we're going to use size for the z-axis. And if I go back and press run, you can now see that the parts are the same size as the chunk. Let's now set up our unload function. So the first thing we're going to need to do is have the ability to get the part inside of this unload function. So currently each part has the name part, but if we use a unique name for each part, then the unload function can find the part in the folder using that unique name. So to do this, I'm going to say part.name equals, and we're going to use the x and z coordinates. So x, and I'm going to use dot dot. I'm going to put a space to split the x and z coordinates, and then I'm going to pass in z, and this is going to be the unique name for this part. So now let's use this unique name to access this part inside of this folder when we want to unload. So to do this, I'm going to say local part equals, and I'm going to say folder, and then inside of these brackets, I'm going to place the unique name, and this is going to return the part into this parts variable. And then I'm going to simply destroy this part, and I'm going to remove this print like so. And let's now test our module. So I'm going back to base plate, turn run on. We can see that the parts are being created. And if I start moving, it will start to load new parts. And once I get to a certain distance, we should see the parts getting destroyed over this side. And here we can see the parts are getting destroyed. Okay, so we've now covered all 4 functions that this plugin will call. Initialize is called when we turn run on, deinitialize is when we turn run off, and load and unload will be called as we move the camera around the workspace. Let me now show you how to configure some properties for the plugin. So currently the chunk has a size of 64 by 64 studs. But what if we didn't want our chunk to have a size of 64 by 64 studs? What if we wanted the chunk size to be 80 by 80 studs? What we can do is select the folder, the same folder we have selected in the plugin, and we're going to add an attribute, a number attribute, and we're going to name this attribute size. And now I can set the size here, and the plugin will use this value as the chunk size. So if I change this to 100, and now if I run the game, we can see that the chunks are still 64 by 64 because we're using 64 here, but what you will notice is as I move away from the center, that the chunks will start to fall behind, and I'm going to get off the edge of the loaded chunks, and that's because we're not calculating the position correctly in our module script. So now we can see the chunks are loading over here while my camera is all the way over here. So we don't have to manually type the chunk size every time we make a change to the attribute, what we can do is set size to nil, and because the instance is passed to us from the plugin, we can use that instance to get the size attribute. So I'm going to say size equals instance get attribute size, and if this size attribute does not exist, we're just going to use the default value of 64. So now if we make any changes to the size attribute, this module will automatically use the correct size. So now let's test to see if this size is working. So let's go back here, press run, and we can see that the parts have a size of 100 by 100. And I can select the folder and I can turn run off. I can change this to a smaller value. Let's try a value of 4 and press run. And now we can see that the parts have a small value of 4 by 4. And if I move, the parts should follow my camera correctly. Okay, what I'm going to do now is change this size back to the value of 64. So it's using the default value. And then I'm going to negate 1 from the size of the part so we can see the edges of the chunk. So I'm going to say size -1. And so now if we run, we can see the edges of the chunk. And once I've loaded all the chunks, I'm going to find the center chunk. So I believe that should be this one over here. And I'm going to move this chunk down so that we can easily see it. And there should be 16 chunks from here all the way to the end. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So the plugin by default will load 16 chunks from the center. So the same way we told the plugin the size of the chunk, we can also tell the plugin how far from the center to load chunks. So to do this, I'm going to add another attribute. It's going to be a number attribute, and this attribute is going to be called load, and I'm going to set it to a value of 4. So if we now turn run off and run on, so we should see 1, 2, 3, 4 chunks load from the center. And if I start moving the camera, and we count the distance from the center to where it gets unloaded, the default value is 32. So I can also set an attribute called unload, and this has to be a number. And I can set this to a smaller value, for instance 8. And now if I start moving, it should unload a lot more chunks, and it should only have a distance of 8 from the center. And if I now change unload to have the same value as load, so let's change this to 4, and if I start moving, we can now see it keeps the perfect circle shape every time. And if I make unload less than load, so if I change this to 3, then unload will be disabled. So if unload is less than load, then it will never unload and chunks will stay in the workspace forever. So I could set this to a value of 0 to disable unloading. And with that, we've now covered everything that the core part of this plugin does. So in essence, it's pretty simple. We select the location, we call run in order to call functions in our modules, and we can use attributes, these 3 attributes here, to adjust the settings of the plugin. So now that we know what the plugin does, and we now have the ability to generate and remove parts from Studio, what about when we play the game? If we run the game, the plugin does nothing and the parts are not generated. So how would we go about making parts generate in game? So in order to have the parts generate in game, what we're going to have to do is create a script that emulates the plugin while we're in game. So the script's going to have to load the modules, call the initialize function when the game first starts, and then call the load and unload functions based on the camera's focus point. You could make this script yourself, but I've provided some presets that are built into the plugin that can create this script for you. So if we open the presets window, and here we can see a list of all the presets that come with the plugin. And if we create a synchronized preset, we get an error. It says Infinite Scripter requires script injection to be enabled in Plugin Manager. So if you don't have script injection enabled for the plugin cannot create a preset. So if we go to the Plugins tab, click on Manage Plugins, and here we can see it says Script Injection Denied. So I'm going to click here, and I'm going to turn on Script Injection, and now the plugin can create presets. So now that the plugin can inject scripts, I'm going to press Synchronized once again, and now we can see that a new script was created, and within this script is a module script, and the plugin will automatically select this preset. If we now look inside of the module script of this synchronized preset, we can see that it has the 4 functions and simply prints for each function. So if we run, we can see it prints just like we had before. Let's also take a look at this synchronized script. So this script will emulate what the plugin does in-game. So it will do the same thing by using the same attributes. It uses the camera's focus property to detect when the camera moves. So it works the same way the plugin does, but the only difference is this will run in-game while the plugin will only run out of game. So now what we can do is this module script that comes with the preset, we don't really need this one because we've created our own. So I'm going to delete this module, and then I'm going to move our module that we placed in folder into the synchronized. And because it's already selected, the plugin will automatically load this module, and we can now delete the folder. And if we run the module, we can see it loads and works just like before when we had it in the folder. And if we now play the game, we can now see that the synchronized script is doing the same job of what the plugin does out of game. So we can see that it loaded the module and it called the initialize function, and it also calls the load and unload functions in order to load the chunks. So if I now walk around with my character, this synchronized script is going to tell this module when to load and unload the chunks. It's also possible for me to set the load and unload attributes in-game. So if you wanted in-game settings to allow the user to adjust the chunk distance based on the performance of their computer, you could have in-game settings that change these attributes. For instance, I can change this down from 16 to 8. And if I start running towards the edge, we can now see it doesn't load at a distance of 16, but loads at a distance of 8. And if I change this up to 128, now we can see it starts to load at a distance of 128. And the same is true for unload. So I could set this to 8 and set this to 8. And now it should unload all the chunks that are further away than 8. Let's now look at the desynchronized preset. So if we go into presets, we can see there's a preset called desynchronized. And one thing you need to know is that all the other presets are based on the desynchronized preset. So the way desynchronized is different from synchronized is desynchronized utilizes parallel Lua in order to load chunks in multiple CPU threads. So I'm going to click on desynchronized and create the desynchronized preset. And we can see that it looks almost identical to synchronized. And if we look inside the module, it has the exact same 4 functions and works the exact same way as synchronized. But if we take a look at the desynchronized script, here we'll see some differences from the synchronized script, and we can see some code related to creating actors in order to reap the benefits of parallel Lua. Now, if you're wondering if making any changes to the desynchronized or synchronized script has any effect on the plugin, it doesn't, because to the plugin's perspective, all it cares about is the modules within. So the plugin will load the modules and call the functions in the modules. It doesn't care what you're doing in these scripts. These scripts are totally unrelated to the plugin. So let me now close these scripts, and we can currently see that the desynchronized script is selected, and if I run, it prints to the output, which is what this module is doing. And if I select the synchronized script and run, this one creates the parts. And that's what we did in our custom module. And if we now just play the game, we should see that both desynchronized and synchronized scripts run. So desynchronized is printing and the synchronized is creating these parts. If we look inside of replicated first, we can see both scripts. If we look inside, you can see that synchronized stays the same with the module inside, where desynchronized looks completely different. We now have two actors within the script, and if we look within the two actors, we have the desynchronized script again, and then we have some bindable events, and within this script we have our modules, and each actor has its own module. So the way this desynchronized script works is it's going to keep track of the camera's position, and it's going to keep track of which chunks have been loaded. And then when the camera moves, it's going to calculate which new chunks need to be loaded, and it's going to send an event using the load bindable event to the actors, sharing the workload between the two, telling them which chunks they need to load. So let's say there's two chunks that need to be loaded, chunk A and chunk B. This script is going to send an event to this actor saying you load chunk A, and an event to this actor saying you load chunk B. And if we look at the output window and scroll all the way to the top, we can see that the synchronized script only gets initialized once, where the desynchronized script gets initialized twice. And that is because each actor gets initialized independently. So both this actor and this actor will be initialized. So that's why the initialized function is called twice, once for this module and once for this module. If we look at the desynchronized script, we can see that there's an extra attribute called actors, and this attribute is not used by the plugin, but only by the desynchronized script. And we currently see there's an actor amount of 2, so we can see the 2 actors here. And I can change this value, and this can be changed in or out of game. So I'm going to change this to 3, and now we can see we have 3 actors. And we can see that the new actor that was created was also initialized. And I can change this to a value of, for instance, 7. And now we can see that we have a total of 7 actors, and all the new actors were initialized. I can also reduce the amount of actors, so I can go back down to 2 actors. And now we have 2 actors, but the actors that were destroyed are not deinitialized. So make sure you take that into consideration. So the way actors affect the chunk load speed is synchronized is going to load 1 chunk every frame, because synchronize calls the load function for all your modules once every frame. So if the player's game is running at 60 frames per second, that means it's going to load 60 chunks every second, where desynchronized will tell an actor to load 1 chunk every frame. So if we have 2 actors, that means 2 chunks are going to load every frame. So that will be 120 chunks every second. And if we increase the actor count to 3, then instead of having 2 chunks load every frame, now 3 chunks are going to load every frame. So now that we know the benefits of using desynchronized over synchronized, let's convert our custom module script to work with the desynchronized preset. So what I'm going to do is destroy the desynchronized module script, this one here that just prints. And then I'm going to move our custom module script into desynchronized, and I'm going to delete the synchronized preset. And because we deleted the synchronized preset, which was selected by the plugin, now nothing is selected. So let's select this desynchronized preset. And if we run our module script inside of the plugin, we can see that it works just like normal and there's no problems. And this is because the plugin always calls the functions inside of your module as synchronized and not desynchronized. So let's now test in-game and see how the desynchronized script works. So I'm going to first turn run off, and then I'm going to play the game. And we can see that we're getting errors. So the first error we're getting is it's saying property instance.name is not safe to write in parallel. And if we look in our module script, and we can see that the error is coming from this line here, and that is because we're trying to set the name of the part in parallel. Another thing we need to know about the desynchronized script is that load and unload are the only two functions that are called in parallel, while initialize is not called in parallel, so it's called while synchronized, and deinitialized is never called by the script. So that's why setting the folder's parent, while not safe in parallel, never produced any errors in our output, because this function is not run in parallel. So how can we go about fixing this problem over here? So one thing we can do is just task.synchronize. So now this part at the top is going to run in parallel, and then it's going to synchronize and then run this part as synchronized. It's also not safe to destroy parts in parallel. So the same way we called task synchronize up here, I'm going to also call task synchronize down here, which is going to allow us to destroy the part. Let's now test our module in the plugin. So I'm going to press run, and we can see it works just like normal. And that is because this plugin is already synchronized when calling these functions. So this is going to be ignored when we run it in the plugin. And if we now run the game and test our module in game, we can see that we're no longer receiving any errors from the desynchronized script, and everything loads fine, and the parts load in game just fine. So while our load and unload functions now work in parallel, we're not really taking advantage of this fact, because most of the work is being done on the synchronized section, and there's almost no work being done in the parallel section. So let's try to move as much work from the synchronized side to the parallel side. So first, I'm going to create the name string over here, like so. And then I'm going to create the position vector 3 over here as well. And finally, size could be calculated right when we initialize. So I'm going to create a new variable called vector size equals nil. And I'm going to say vector size equals, and we calculate the vector 3 up here. And now I can set this to vector size over here. Now, if we run the game, it may seem like everything is working fine, but there's still one more problem we need to fix. And that is, if we remember from before, each actor is initialized independently. So actor 1 is initialized and actor 2 is initialized. And if we look at the module script, we can see that the initialization creates a folder and places it into workspace. So that means both actors are creating a different folder and placing it into workspace. So here we can see we have two folders, one created by one actor and one created by another actor. And each actor is putting the parts for the chunk in their own folder. And if we create another actor, so if I increase actor count to 3, we can now see there's 3 folders, and this one has no parts inside because we haven't loaded anything into it yet. So if I move a bit, we can now see that these blue parts that are selected are being loaded by actor 3. But the problem lies when we try to unload. Just because an actor loaded a part doesn't mean that the same actor is going to unload that same part. Each actor can unload a part from a different actor. So what that means is this actor may try to unload a part placed in a different folder, and that's going to produce an error. So if I keep walking and start to unload parts, we should see that some of them produce errors. So we can now see we're getting errors, and we can see that some of them are not getting unloaded. It's because the actor is not able to find that part within its own folder. So what we need to do is make all the 3 actors use one folder. So before we just blindly create the folder for each actor, what I'm going to do is I'm going to use find first child in order to attempt to find a folder that has been pre-created by a different actor. So to do this, I'm going to say folder equals workspace, find first child, and we're going to try to find the folder. And then I'm going to say if folder is not equal to nil, then return. So if a folder is found, we're just going to exit out of this function early, but if the folder is not found, then we're going to create it. So if we test the game again, we can see that we have 2 actors, but instead of having 2 folders, we now only have 1 folder. So both actors are placing the parts within the same folder. So if an actor tries to unload a part that it never created, it should still be able to find it within the folder, and so we should no longer receive errors when unloading chunks. So here you can see I'm unloading chunks and we are getting 0 errors. You may feel that everything I've explained up to this point in the video is too complicated and you don't understand what's going on. Now, I would like to say that don't worry, everything I've explained up to this point in the video is not required to understand in order to use the plugin. I've created some easy to use presets that will allow you to do things like generate infinite terrain without the need to understand anything I've said up to this point. So let's now delete our desynchronized preset, and let's go into the presets window and scroll down to terrain, and let's create a simple terrain preset. And if we now turn run on with the simple preset selected, we should see that this preset generates terrain. And I can turn run off and I can play the game. And we also generate the same terrain in game. Now this preset has 3 modules, and if we look inside we can see the 3 modules, and the only module you need to understand is the data module. The chunks and functions module are not required to understand in order to use this preset. But let's just take a quick peek at the chunks and functions module. So let's open the chunks module, and the job of this module is to get the data from the data module and to use that data to generate the terrain. And let's also take a quick look at the functions module. And what this module does is provide some helper functions in order to do some common tasks. So let's now look at the data module. So this is the only module you're going to need to change in order to generate your own custom terrain. So here we can see there's 3 functions: initialize, height, and desynchronized. Now to make this slightly more simpler, I'm going to comment out all this code down here, and we can ignore it for now. And also let's comment out all this code down here so we can ignore it. And let's just simply set material to grass for now. So ignore all this code down here and let's just look at this code up here. So let's first take a look at the initialize function. What this function does is it gets the noise function from the functions module. So if we open the functions module, we can see that there is a function here called noise. And what we're doing is we're getting that function and saving it into this noise variable. So now let's take a look at the height function. This function receives 5 values. The first 2 values are the X and Z position of the terrain in studs. And the next 2 values is the X and Z position in voxels. Now, if you're not too sure what this means, we can ignore this because most of the time you're going to be using the X and Z position in studs. And finally, we'll receive a table, and this table is used to send data back to the chunks module, and the chunks module is going to use this data to generate the terrain. So this function is requiring us to set two values within the data table. We must set the height value, and here you can see I've set it to 0, and we must also set the water height value, and here you can see I've set to 0.001. And finally, let's take a look at the desynchronized function. This function receives the exact same values that we did in height. The only difference is now inside of the data table, there is an extra value called slope that we can use to detect how steep the terrain is in this area. So what this function requires us to do is set the material of the terrain in this section. So let's see what the terrain looks like if we always set the height to 0 and we always set the material to grass. So I'm going to go back to base plate and turn run on, and now we can see that we have flat terrain that is always grass. Let's see what would happen if instead of always setting the height value to 0, if we set the height value to X. So let's change 0 to X. Let's go back to base plate and press run. So now we can see as the X position increases, so does the height of the terrain. And as the X decreases, the height also decreases. Now, currently the water height is at 0.001, but if we wanted to disable water, what we could do is simply do negative math.huge, and now if we go back to base plate and run, we should see that the terrain goes down past negative and there's no water down here. So water should no longer spawn if we set the water height to negative math huge. Let's now make it so that if the height is above 0, the material will be grass, but if the height is below 0, we'll use the material of sand. So any values we store inside of this data table will also be in this data table in this function, because these two data tables are the exact same table. So we can access this height value inside of our desynchronized function. So what I can do is say if data height is more than 0, then data.material equals grass, else data.material equals sand. And so if we go back to base plate and press run, we can now see that if the height is above 0, it's grass, and if it's below 0, it's sand. Let's now use the modulus operator on this X value. If you're not too sure what the modulus operator does, I have a video on my channel that talks about the modulus operator, and I'm going to use the value of 64, so X modulus 64. And let's go back to base plate and press run. And now we can see that the terrain goes up to 64 and then loops back down to 0, up to 64, down to 0. And now we get this weird wave effect. So let me now show you how to use the slope value that we can find in this data table. So instead of using the data height, I'm going to use the data slope. And I'm going to say if slope is less than the value of 10, then we're going to use grass. But if it's more than the value of 10, we're going to use the material rock. And if we go back to base plate and press run, we can now see that for this part it's grass, but for this very steep part it's rock. So let me show you some other ways we can set the height. For instance, instead of using X modulus 64, what we could do is say math.sin, and I could pass the X value in. And if I come back to base plate and set run on, we can see that we get these very small little waves. And if I increase the magnitude of these waves, I can multiply this value by, for instance, a value of 10, turn it back on, and now we get this. And I can divide the X value to reduce the frequency of the wave. So let's divide it by 4, and we get something that looks like this. And I can further divide it by a value of 20 instead of 4, and that should give us waves like this. And I could even add Z to the X like this, and this is going to make the waves go in a diagonal direction like this. Inside of the functions module, there is a function called magnitude, and this is going to give us the magnitude using the X and Z values. So let's go back to data and let's bring in this magnitude function. So what I'm going to do at the very top, I'm going to say local magnitude equals 0. And then I'm going to copy this and bring in the magnitude function into this module. So now what I can do is use the magnitude function to calculate the height. So let's remove this. Let me use the magnitude function, and I'm going to pass in the X and Z. So passing X and Z. And if we now test this to see what happens, we can see that we create like a funnel. So this is a position of 0, 0. So the magnitude is 0 here. And as the distance from the center gets further and further away, so does the height. And now we can see that we have a terrain that continues to go up in all directions from the center. We could also set the magnitude to a negative number. So if we set this to negative magnitude and run, we can now see instead of the terrain going up as the magnitude increases, the height now decreases as the magnitude increases. And we get this shape like this. And let's say that we wanted it to only go down to a certain height. What we could do is use math. So I could say math.max, and then I can pass in a value of, let's say, negative 50. So if the value is under negative 50, it's going to pick this value instead of this value. So it's going to pick whichever number of these two is highest. So if I go back here, press run on. So now we can see it goes down to negative 50, and then once it reaches negative 50, now the terrain is always flat. And for instance, if I wanted the height to start off at a value of 100, so I could do 100 negative magnitude, and once it reaches negative 50, it's going to become flat. So go back here, and now we can see it starts at a value of 100, goes all the way down to negative 50, and then it's going to be flat. And this is a good way to make islands. So what I could do is bring water back in, like so, and I could also divide the magnitude if I don't want the slope to be so steep. So I can say divided by 3. And if I come back, press run, we can now see that this slope goes down to negative 50, so which should be under the water, and becomes flat. We could also use this magnitude function with the sine wave. So let's do math.sim, and I'm going to pass in the magnitude, and I'm going to delete this over here. I'm also going to hide water once again, so negative math.huge. And I'm going to multiply this sine wave, so the magnitude is higher. And I'm also going to divide the frequency. And if we go back, turn run on, now we can see that we get something that looks like this. So here we have the sine wave, but unlike before, because we're using the magnitude, it now makes these kind of circles, which is kind of cool. we can also use this magnitude function to calculate the material. So if I wanted my terrain to be limited and not go on for infinity, what I could do is use this magnitude function, and I could say if magnitude is greater than 100, then I'm going to return the material of air. So let's return the material of air. Else, I'm going to return the material of grass. So let's delete this. And if we go back to base plate, turn run on. So now, once the magnitude becomes greater than 100, all this part over here is going to be air. And here we can see we have a limited amount of terrain that generates. And I can increase this 100 value to say something like 500. Turn run on. And now it should generate for 500 studs from the center. Let's now take a look at the math noise function. So this function returns a Perlin noise value. And if you're not too sure what Perlin noise is, we can look at Wikipedia and we can see some information about Perlin noise here. We also have an image to see what Perlin noise looks like on a 2D axis. So this is what Perlin noise would look like. So it's a little bit like the sine wave, but it's not uniform like the sine wave. So let's now use math noise in our height function to calculate the height. What I'm going to do first is get rid of this part here, and I'm always going to use the material of grass. And let's get rid of this here. And now let's use math.noise, and let's pass in the x value, and let's leave the y and z coordinates at 0. And if I now go back to base plate and press run, we can see that the math noise is always returning a height of 0. So why is this happening? So if we read the math noise function on the documentation, we can see it says if x, y, and z are all integers, the return value will be 0. So if we return numbers that are not fractions, then the value that it returns will always be 0. But if we make all x, y, and z fractions, then the value should fluctuate between -5 and 0.5. So the x and z coordinates of the terrain are always integers, but this noise function will return 0 if we only enter integers into the coordinates. So what we can do is we could divide this x value to make it a fraction, or we could also multiply it by a value like this to make it a fraction. And if we go back to the workspace and turn run on, now there are very small bumps we can see, but they're kind of small. So let's increase the magnitude the same way we did for the sine function. So let's increase this to a value of 50. And if I press run again, and now we can see we get waves just like we did for sine, but these waves are not uniform like the sine wave. So sometimes there's small waves, sometimes there's big waves, and sometimes there's no waves. Let's now use the z-axis to make two-dimensional Perlin noise. So as a second value, I'm going to place z multiplied by 0.01, just like the x, and go back to base plate, press run, and now we can see two-dimensional Perlin noise. Now, you don't have to use the same scale for the x and z coordinates. So for instance, I can change this to 0.1 instead. And if we have a look at this, now we can see that x has waves that are very wide. The frequency is very low, where the z frequency is very high. So that's how we can see that this part here allows us to adjust the frequency of the Perlin noise. Now, this noise function allows us to have 3D Perlin noise, but our terrain is only in 2D. So The third axis we could use as a seed to generate different terrains. So what I like to do is just use a random number, and if we remember, fraction numbers are better because if we use integers, there's a chance that it will just return a value of 0. So let's do 0.123. And now we use the x-axis, we use the y-axis as a seed, and the z-axis like so. And let's change the z back to the same scale as x, like this. And so now we can use the y-axis to create different kinds of Perlin noise for our terrain. If you've used my Infinite Terrain plugin before, these numbers may look familiar to you. So let's take a look at my Infinite Terrain plugin, and we can see that this plugin allows you to create noise, and it takes in a seed value, a magnitude, and a scale, and also has an extra clamp, which we're going to cover later. So the seed we can copy and replace this like so. Let's also set a material, and I'm going to set it to dirt. And for the scale, let's set the scale the same, like this. And we're going to ignore clamp because -10 and +10 is pretty much like using math huge. Let's also set the water height to -math huge. So we do this like this. And one more thing we need to know is Infinite Terrain uses the grid X and grid Z, not the X and Z. So we need to replace X and Z with grid X and grid Z, like so. And one last thing I'm going to do is shift the terrain down by -4 studs. And this is going to allow Infinite Scripter's terrain to appear above the terrain generated by Infinite Terrain. And I'm going to go back to base plate and turn generate on. And now I'm going to turn Infinite Scripter on, and we should notice that Infinite Scripter's terrain should perfectly match Infinite Terrain's noise. So this noise and this noise should be exactly the same. So we should cover this bump perfectly. So let's turn one on. And we'll see the exact same bump still exists for Infinite Scripter. And if you have multiple noises on your Infinite Terrain plugin and you want to convert all of these noises to Infinite Scripter, the way this works is we first set height to 0, and then we add each layer of noise on top. So we do plus equals, like so, and there's 3 noises, and so we would add 3 times, and we would use the same scales, the same seeds. So this would be this seed, and this would have this seed, like so. And this will produce the same noise as all 3 layers of this noise. But for all new works, instead of using grid X and grid Z, I would recommend using X and Z for all new works. And also, instead of using the math noise function directly, I've created a small wrapper for this function inside of functions. We can see it here. So it takes in the X and Z, takes in the seed, scale, and magnitude, and kind of does all the calculations here for you. So you may feel more comfortable using math noise directly, or if you like, you can use the noise function that I provide in the functions module. And here we've got this noise function. So let's use this function instead. And the first 2 values are the X and Z. So let's pass in X, Z. The next value is the seed. So let's pass in a random seed, like so. And the next value is the scale. So let's get the scale. And the next value is the magnitude. So now this wrapper function is going to call math noise for us and pass in all the values where they need to go. Now, Perlin noise does not have to be only used by height. we can use this noise for many things. For instance, if I wanted to, I could use it for the water height. So let's paste this into water height and let's set height to 0. I'm going to reduce the scale to 0.01. Then I'm going to come over here, press run, and now we can see that instead of the terrain going up and down with the noise, now we have water that goes up and down with the noise. Or we could even use the noise to calculate which material to use. So what I can do is say local noise equals, and I can move this over to here. Let's set water height back down to negative math.huge. And I can say if noise is greater than 0, then we use grass, else we can use sand. And now if we run, we can see that based on the noise, that's what material will be used for that section of terrain. So some parts are grass and some parts are sand. And we can also use noise to determine which biome we're in. So we can create a new value, and I'm going to store this in the data table so that we can access it from the desynchronized and from the height section. So I'm going to say data.biome equals, and I'm going to use this noise value. And then I'm going to create 2 heights, one for each biome. So I'm going to say local height 1 equals, and this biome is going to be very bumpy. So let's copy this noise function, and I'm going to have a magnitude of 100 and a scale of 0.05. So this should be a very bumpy noise. And if I use this noise and set it to the height so that we can have a look at it, and I'm also going to comment out all this code down here, and I'm just going to set the material to grass for now. So let's just set material to grass, and let's just check out, see what height 1 looks like. So we'll go back to base plate, press run, and we can see that height 1 looks like this. So it's very bumpy and very pointy. Let's now create our second height for the other biome. So I'm going to copy and paste height 1, and I'm going to name this one height 2. And I want this one to be not so bumpy and not very pointy. So I'm going to set the magnitude down to 50, and I'm going to have a scale of 0.05. And if we set height to height 2 so that we can have a look to see what this one looks like, I can press run, and we can see that this one has smooth rolling hills as the noise. So now what we need to do is use the biome to lerp between these 2 heights. Now if we look into my functions module, we can see that we have a function called lerp, and we can use this to lerp between the 2 heights. Another thing we're going to need is to normalize the biome. So what that's going to do is add 0.5 to the noise, and it's going to clamp the noise between 0 and 1. So we're going to need both normalize and the lerp functions inside of this module. So we're going to do this the same way we did for these, and we're going to use normalize and lerp, and I'm going to copy this part here and then save these functions into these variables. So now we've retrieved the normalize and lerp function from the functions module. So let's now first normalize this biome noise. So to do this, we're going to simply do data.biome equals normalize, and we're going to pass in the data biome. So this is going to convert the biome noise into normalized biome noise. And then we can now use the lerp function with this biome noise to lerp these 2 heights and set it to the data height. So I'm going to say lerp, and we're going to use height 1 and height 2. So we're going to lerp between these 2 values, and we're going to use the biome as the alpha. for the lerp. So this biome is going to allow this function to lerp between these two values. So let's go and test this to see what it looks like. So now we can see we have some sections that are smooth and some sections that are bumpy. But we can see that the transition between the biomes is very harsh. And we can also see that the biomes are kind of small in size. So let's adjust these. In order to make the biomes larger in scale, we just simply scale this down. So let's try 0.005 and see what that looks like. So now we can see that the biomes have slightly increased in size. I can make it slightly larger by going down to 0.001. And this looks like the biomes are a lot larger now. So here is one large biome and here is one other large biome. And in order to make the biomes transition more smoothly, we can simply adjust the magnitude. So a smaller magnitude will make the transition not as harsh. So let's reduce this down to 20 and see what it looks like. And let's have a look at the transition. So the transition still looks pretty harsh. So let's further reduce it. Let's go down to 5 and run. So now we can kind of see that the bumps start off small. And as we transition into this biome, the bumps are a lot larger. Let's reduce this even more. So let's go down to 2 and try again. So now we can see that the lerp, it lerps slowly from this biome into this biome. And here we have small, very tiny bumps and very large bumps. And we can further reduce the magnitude. So let's go down to 1. And now we can see that it takes a very long time, almost never able to reach the super smooth part of the biome because the magnitude is not big enough. So here is the smooth section and very slowly goes up to the bumpy section. And let's now also use this biome value to select a material. So what I'm going to say is if data.biome is more than, now normally we would use the value 0, but because we've normalized the biome, it's now the center of the biome is 0.5 because the value goes from 0 to 1. So if it's greater than 0.5, then we're going to use grass, else we're going to use sand. And if we test this, we can see that the smooth areas are grass and the bumpy area is sand. Let's change them round. So let's make the smooth area sand and the bumpy area grass. And let's move this magnitude up to 2 so it transitions slightly quicker. So now you can see we have smooth sand that transitions into bumpy grass. Let's now simplify the module. So I'm going to set height back to a value of 0 and I'm going to delete all this over here and I'm going to simply always set the material to grass. Let's now take a look at the Spline tool. So I'm going to open the Spline window and here we can see we have a line graph and I can move these points up and down by left clicking and dragging. I can create new points by left clicking and dragging. I can remove points by right clicking on them and I can create as many points as I like. For instance, I can create points that look like this. And here we can set the name of the spline. And this value allows us to adjust the smoothness of the spline. So here we can see the points go like this. And if I change this to a value of 2, we can see it goes like this. I can also use the mouse wheel to scroll up and down to adjust the smoothness. And the next value allows us to adjust the resolution of the spline. So if we look at these dots, as I increase this value, the number of dots increase. And as I reduce this value, the number of dots decrease. The spline resolution has zero impact on performance, so feel free to have any value you wish for the spline resolution. So what the spline window allows us to do is convert one number into a different number. Now if we look at this point here, it's not perfectly on the handle. We can see this more if I increase the smoothness. So if I set smoothness to 0, now this point will go perfectly on the handle. So what this means is when we input a value of -1, it will output a value of -1. But if I move this point to the top, now if we input a value of -1, it will output a value of 1. And I can create another point, and I can say if we input the value of 0, I want to output the value of 0. So now if we input the value of -1, and as we increase this -1, it will lerp down to the value of 0. And once we reach 0, then it's going to start lerping back up to +1. So let's save this spline into our project and let's import it into the data module. So to do this, I'm going to name this test spline, and I'm going to select where I want to save it. So I want to save it inside of this simple script, and I'm going to press save. And now we can see we have a new module called test spline, and we can also see it inside of the plugin. And we can take a look inside of this module. So here we can see all the points being saved. That's all these points along here. We can also see that the 3 handles have been saved. And we can also see the smoothness value of 0 has also been saved. And to access this spline, we can access it the exact same way we access the functions module. So what I can do is say local test spline equals nil, and then I can say test spline equals, and the same way we get the functions module, we can get the test spline module, like so. If we take a look at the functions module, we can see that there is a function called spline, and this function requires 2 values, a spline and a value. So if we go back to our data module, and we can get this function the same way we got all our other functions. So I'm going to copy this and rename it to spline. So now we're getting the spline function and bringing it into our data module and saving it into the spline variable. And let's now simply use this function inside of initialize. So spline, and the first value is the spline. So let's pass in the test spline into the function. And let's just pass in a value of -1. So -1. And if we print this value, so let's put this inside of print. Now, if we look at our spline, if we pass in the value of -1, it should output the value of 1. So let's load our module, press run, and we can see it printed 1. And what I can do now is adjust the spline. So instead of printing the value of 1, let's make it print the value of 0.123. So now, if we input the value of -1, it should print 0.123. And to update the spline, if I select the here and press save, it's going to create a brand new spline. But I can select the previous spline and press save, and it will overwrite the previous spline. And if I change the name, for instance, I've had to test spline 2 and press save, we can see the name was updated to test spline 2. So let's rename it back to test spline. And now we can see, if we look in this module, that the value starts at 0.123. And if I press run, we can see instead of printing the value of 1, it now prints the value of 0.123, the same way we set it here. So let's now use the noise function once again. So I'm going to use the noise function to set the height. And remember, the first two values are the X and Z. Then it requires the seed. So let's use 123.123. Then it requires the scale. Let's do 0.01. And then for the magnitude, let's do 50. And let's go over and see what this looks like. And let me go back to 0. So we can see that the noise currently looks like this. So let's now use the spline function on the noise. So what I'm going to do is create a new variable called noise equals, and I'm going to set it to this noise. And then I'm going to use the spline function. And instead of passing the value of -1 all the time, I'm going to pass the noise value into this spline function. And let's now delete this print. So I'm going to remove the print, and let's go to baseplate and press run. So we can kind of see small bumps, but it's acting kind of strange. So let's work out why it's looking like this. So the spline function will clamp the noise value between -1 and 1. And we can see this if we look at the functions and we go to spline, we can see it's clamping the value between -1 and 1. So even though we have a magnitude of 50, this spline function is clamping the noise down to -1 and 1. So let's reduce the magnitude to 1, and let's multiply the spline in order to have the magnitude of 50. And if we test the terrain once again, we can now see we currently have some flat areas, and we have a part that's part of the bump. So the flat area is this part here, and the bump area is this part here. So this is the part of the noise that is negative, and this is part of the noise that is positive. So let's play around with this spline a little bit so we can see what kinds of effects we can do. So for instance, if I move this back up to 1 and select the test spline, press save, turn run off and on, now we can see instead of this part being flat, it now goes like this, and then for the negative side converts into a positive side. So we can see the V shape of the spline here. Or what I can do is have this and this like so, and move this down. So negative is always going to return the value of -1, and positive is going to return the value of +1. So let's save, turn run off and on, and now we can see for the negative side it returns -1, and for the positive side it returns +1. And if I wanted the transition between negative and +1 to be smoother, I could increase the smoothness. So if we set the smoothness to 3 and save, turn run off and on, we can now see that the transition is smoother. If I wanted to add an indent on the top of the noise, what I can do is let's reduce the smoothness back down to 1. And let's add an indent at the top, and let's press save and run again. And now we can see that it goes up, and then once it gets to this peak here, it goes back down to here, and then it starts going back up again over here. Or if I wanted to, I could move this down and remove this point, press save, turn run off and on, and now you can see it continues to go down once it reaches this peak. And let's create one last spline. So I've set smoothness to 0, and I'm just going to make steps that go up. Let me slightly increase the resolution to 55, and then I'm going to have steps that go up like this. Some flat areas, and then a step, flat area, then a step. Now you could spend more time doing this nicely, but I'm going to do it quickly and keep doing this like so. And if I save this spline, turn run on, you can now see that just like the spline, we now have steps in our terrain. So let's now use a spline to make a V shape, and we're going to use that V shape to make rivers. So the first thing I'm going to do is delete all these points. And I'm going to set this up here, and I'm going to set this at 0. And we only need 3 points to make the V shape. So 1 point up here, 1 point down here, and 1 point over here. And I'm going to save this spline and close the spline window. And if we turn run off and on, we can see that we currently have this, but this is not what we want. So let's turn run off, go back into our data module. And the first thing I'm going to do is increase the magnitude of the noise. And what this is going to do is clamp the edges so that we have flat parts. So if I change this to 5, come back to base plate, turn it on, and now we can see because the noise is going off the edge of the spline, it's returning a flat value for the edges. And we have this V shape. Now these rivers are kind of deep, so let's turn run off. Let's reduce the magnitude to something like 10, and let's also reduce the noise, the frequency. So let's try 0.001. Let's go back, turn run on, and now we should see something that looks like this. Okay, and let's turn run off and bring the water back. So water height equals 0.001. And let's have a look what this looks like. So you can see we have something that looks like this. And these kind of look like rivers now. And if we wanted to, we can add octaves to our river noise. So let's add more octaves. So what I'm going to do is say noise equals 0. And then I'm going to say noise plus equals this noise here. And then I'm going to create another octave. And I want this to be, let's make it double the frequency. And let's share the magnitude. So if I do a magnitude of 2 and a magnitude of 3, it should add up to a magnitude of 5 when they're both added together. And let's go back, turn run off and on, and let's see how this affects our rivers. So we can see that by having more octaves, we can adjust the shape of the river. So here we can see it goes thin and has this kind of thick area, and it looks something like this. So let's now simplify the project once again. I'm going to delete all these functions. I'm going to delete the test spline. I'm also going to delete it from the project. I'm also going to delete all these and delete this. And I'm going to set height back to 0 and delete this. And let's set water height back to negative math.huge. And we're always setting the material to grass. And let's go back to the workspace and let's open the map tool. This map tool gives us some tools to allow us to draw a map in the workspace. So let's first click on the set tool, and we can see we have some values we can adjust here. We can adjust the brush size, we can adjust the value we want to set, and we can also add some noise to this value. And if I click on the spawn location, we can see that nothing happens. And this is because it's currently not enabled. So if we turn enabled on, we can now see the map in workspace. And if I turn enabled off, it gets hidden. And if I turn it back on, we can see it again. And now I can start drawing the map. And if I want to set a value of 8 and start drawing, we can now see I'm setting a value of 8. It's also possible to use the mouse's scroll wheel. So if I scroll on top of this 8, I can adjust the value. But if this window is too small and I try to scroll, it will not affect the value and it will just scroll up and down. So make sure this window is big enough so that we can scroll up and down on these values. And now I can quickly adjust this value to be whatever I want. One thing to note is if we click out here where there is nothing, we can see that the set tool does not work. And that is because we must use something as a reference. So if I click here, now it works. But if I click over here, nothing happens. So make sure you have something in your workspace to click on to use as a reference. Let's now try the erase tool. So this tool allows me to erase, and I can come over into a bird's eye view like so and erase like this. Or I can even press the reset button and this will erase the entire map. So if I press reset, everything gets erased and I can start from scratch. Now let's look at the increment tool. So this tool allows us to increment the map. So if I click over here, we can see that this part of the map starts incrementing, and we can adjust the brush size, we can adjust the hardness of the brush and how much to increment the map. We can also add noise to our brush. And one thing to note about the increment tool is if I go to the edge, it does not create more map data. So if I want to create more map data, I have to use the set tool, and then I can start incrementing this area of the map. If I click over here, it just increments the preset map data. And let's now look at the flatten tool. So this allows me to flatten the map. So I can come over here and start flattening this map. And if I wanted to, I can make another layer here, another layer here, another layer here, and do something like this. So here we can see the flatten tool allows me to flatten the map. I can adjust the hardness. So we can see that the edges of the flatten tool are smoothly going down, where if I set the hardness to 100, now we can see it instantly flattens to the height. And if I select the smooth tool, we can smooth the map. So here we can see I can start smoothing this map like so. And I can adjust the smoothness. So for instance, I can go to 200 and now it should make it even smoother. And if I want to, let's set a height to 50 and let's make this map a bit bigger. So let's increase the brush size to 20 and make this part over here. And let's set this back to 0. Let's make this part over here. And now let's test the smoothness. So if we have a smoothness of, let's say, 30, and I start smoothing this bit over here, we can see that the smoothness, because we have a low smoothness value, it doesn't have a very smooth transition. And if I increase this to 50, we can now see we get a smoothness that looks like this versus this. And if I increase this to 200, we can see that we get a smoothness that looks like this. And finally, let's do a smoothness of 1000. And we can see that this one takes a long time to reach its target height. And we can see a big ramp that looks like this. Okay, let's now turn the smoothness tool off and let's reset and disable the map tool. And let's turn this off and let's go into data and let's add some noise to the height once again. So I'm going to use this noise function. And first we need the X and Z, then we need the seed, then we need the scale 0.001, 01, and for the magnitude, let's do 50. So if we come back and turn run on, we should see the terrain gets generated. Now what we can do is open the map tool once again, And if we use the copy tool and make sure to turn enabled on, and if we start drawing, we should be able to draw a map, but we currently can't see it. But if we turn the terrain off, we can see the map. Now the reason for this is we have an offset set to -2. But if I change this to a +2 and start drawing, now we can see the map being drawn above the terrain. And if I set this back to 0 and start drawing, now we can see it perfectly aligns with the terrain. Okay, so now that we've covered all 6 tools of the map tool, let's reset, let's turn the terrain off, and let's just make a circle around the spawn location. And I'm going to click here and press the save button. And this is going to save the map. So we can see a folder here, and we can see inside of this folder is modules, and each module provides the data for the map. And let me now disable the map tool and turn off set and close this window. And let me show you how we can load this map into our data module. If we look at our functions module, we should see a function called load map. And we can use this to load this map folder. And this requires the folder that we want to load and a list of all the modules. So let's go back to data and let's get this function, the load map function, into our data module. So I'm going to say load map equals nil, and we're going to bring this function in the same way we've done it for the entire video. And now we can use this function to load this map folder. So let's create a new variable called map equals nil, and this is going to store the map data. And let's load, using the load map function, the data into this variable. So I'm going to say map equals load map, and then we're going to first pass the folder. So we're going to say instance dot, and we're going to pass this folder here. So we're going to pass the map folder. Now we can rename this to anything we like. For instance, we could have it called test map, and then we would have to make sure this was also called test map, like so. And finally, it wants the modules, which is this table here. So we just simply pass this modules table into the load map function. And now this is going to load all the map data into here. And now what we can do is use this map data to set our height. So what I'm going to do is say if map, and we're going to first use the x coordinate is not equal to nil, and we're then going to check the second dimension of the array. So it's a 2-dimensional array that requires the x and z coordinates. But if we remember, this is in studs, but the map is saved in grids. So we need to use the grid value instead of the stud value. So let's change this to grid x, and let's change this to grid z, and say if this is also not equal to nil, then we can set the height to this value here. So we're checking the first dimension of the array, and then we check the second dimension of the array, and if they're both not equal to nil, then we're setting the height to that value. Else we could set the height to any other value, but let's just set it to the noise value if the map is not found. And if we go back to the workspace and press run, we should now see that the terrain copies the map, but when the map does not exist, it does the noise. And what I can do now is turn run off, open the map tool again, and press enabled, go to the set tool and draw a path like this, and then press save. Now, just like the spline tool, if I select the simple script and press save, it's going to create a brand new map. But if I want to overwrite the previous one, I select the map I want to overwrite, and if we look inside, we can see there's 4 modules in this one, and if I press save, it's going to overwrite the previous modules and add or remove whatever modules are required to save this map. And now I can turn run on, and we can see that the terrain follows this map. I can turn this off to disable the visualization of the map and just look at the map through the terrain. But if we look at the edges of the map, we can see that it doesn't transition nicely from the noise to the map value. So let's now use the copy tool to have the terrain transition from the noise to this map value. So to do this, first thing I'm going to do is press reset to delete the entire map data, and then I'm going to save it to overwrite the previous map data. So now we can see we have an empty table, an empty folder, and if we turn run off and on again, we should see that the map has disappeared. And now we can go to the copy tool and start copying the terrain. But there's one small problem. If we want the copy tool to copy the height exactly, we must use an offset value of -2, and that is because Roblox's terrain has an offset of 2 studs. But if we use the offset of -2, we now have the problem that the map is going to generate underneath the terrain, and we won't be able to see which parts we have copied. So what we can do is, instead of setting an offset of -2, we could set an offset of 0 and then come into our data module and subtract 2 from the map. So I can go -2 like this, and now I can turn enabled on and I can start copying the terrain. And then I can turn the terrain off, and now I can start setting the center to a value of 0. So let's set the center part to a value of 0. And then I can use the smooth tool to smooth. Let's reduce the smooth down to 50. And let's smooth, and being very careful that I do not change the edges because I want that to perfectly align with the original noise. So I'm going to go around and smooth these edges like this. And then I can save this map to the test map. Press save. Now, because there was nothing inside of here, it didn't realize that this was an original map. So let's move all this into the original folder, and let's delete this. Okay, and now I can turn map off, turn run on, and now we can see that it smoothly transitions to the flat map. Now currently we've only been using the map to set the height, but maps can be used for almost anything. For instance, I can come over to copy, and I can set, let's reset, and let's set the brush size to a value of 4. And let me start drawing, let me turn enabled on, and let me start drawing a path, like so. And now I can use this map to set the material. So let's save a new map. So I'm going to press save, and I can turn this map off. I can close this window, and let's load this second map into our data table. So I'm going to call this one map 2, and I'm going to load it in the same way we did the other one. So this one's going to be called map, and it's map 2. Okay, so now the same way I checked the map over here, I'm going to check the map over here as well. But instead of checking map, I'm going to check map 2, and let's check to make sure that map 2 is here. So I'm going to say if map 2, then I'm going to set the material to cobblestone, but if the map does not exist, then I'm going to set the material to grass. And if we come back, turn run off and turn run on again, we can now see that this second map that I've created is used to set the cobblestone material. And another thing I can do is I can turn run off and open the map window once again, and we can turn enabled on to see the cobblestone path, and we can use the set tool to set different values for different materials. So for instance, if the value is, let's set the value of 1, and let me start painting in the value of 1. And let's also paint in the value of 2, and we can use this for a different material. So let's set all this part here to a value of 2. And now I can make sure to overwrite the previous map of the cobblestone. So I'm going to press save to overwrite this folder. I can turn map off, close this window, and in here I'm going to check the value of this map. So I'm going to first save it into a variable, and we can name this whatever we like. Let's just call it value for now. And I'm going to say if value equals 1, then set the material to cobblestone. I'm going to say else if value equals 2, then we can use the material of, let's do cracked lava. And finally, if the value is not 1 or 2, so if we accidentally set the map to another value, we could just set it to, for instance, air. And now, if we go back and turn run on, we should see that this part that we set to a value of 1 is now cobblestone, and this part that we set to value 2 is cracked lava. Let me now show you how to spawn models on your terrain. So this preset comes with a chunks module, and this module does not support models out of the box. Now we could change this script, but there's no need because I've made a preset that supports models. So let's close these. Let's delete the simple preset, and let's go into presets. And in here, under the terrain group, we should see a preset called models. So let's click on this preset, and here we can see we have a new preset. And just like the other preset, we have 3 modules. And just like the other preset, you don't need to understand the chunks and the functions module. The only module we need to understand is the data module. And if we turn run on, we should see terrain generate with models being randomly spawned around the terrain. So let's now look at the data module, and let's simplify this module so it's easier to understand. So I'm going to delete all this part, and I'm just going to simply set the material to grass, and I'm going to delete all this part, and I'm going to delete all of this part. And for now, we can just comment out this part here. So let's quickly overview this module. So we have the initialize function, just like before, and I'm getting the noise function from the functions module. So this is the exact same functions module as before. We have the exact same functions as before. And the only difference is I'm also receiving the random noise function, which is this function over here. I'll talk about this later on. And we're also getting the models. So we have 2 models, and these are simple models. One's called model 1, one's called model 2, and we're saving them into these 2 variables here. And we can have a quick look at these models. So let's move this into workspace. And this is just a simple model. Let's move the spawn location down. So this model, and the only thing we've done to it is we've edited the pivot point to be at the bottom of the model so that the terrain aligns correctly with the model. And the same with model 2. So let's bring model 2 into here. And this is just a blue model with a blue part inside. The part has a size of 3 by 3 by 3. And this is also aligned to the bottom using the edit pivot tool. And there is a height function. Just like before, we can set the height and water height. And if we set water height to negative math.huge, we can disable the water. And we still have the desynchronized function. And here we can set the material. And currently we're just setting everything to grass. And we have one more function, which is called synchronized. And this part we can use to clone our models. So let's just blindly clone model 1 and use that for every terrain voxel. So I'm going to come over here and say local clone equals, and I'm going to clone model 1. And then I'm going to use pivot 2 to position this clone. So clone pivot 2. And let's create a C-frame. So cframe.new. And for the x-axis, we're going to use x. For the y-axis, we're going to use the height. And for the z-axis, we're going to use z. Now, this chunks module is going to set a folder to this data table for us. And we can use this folder to place our model in. So what I'm going to say is clone.parent equals, and we're going to use the data.folder. So this chunk module is going to create a folder for us, and we're going to use that folder to parent our clone. Now, because we're going to be blindly cloning a model for every voxel, what I'm going to do is select the models preset, and I'm going to reduce the load distance to 1 so that we don't crash Studio. And then I'm going to turn run on. And now we can see that we're spawning a model for every voxel. Okay, so instead of spawning the model for every voxel, what if we only want to sometimes spawn a model? Well, we could use Perlin Noise. We could use the noise function that I provide. We could even use the map tool to map where to place the models. And now I'm going to show you why we should not use math.random. So let's say we use math.random to get a random value. And if random value is, let's say, if random value is less than 0.2, then we clone the model. And if we go back to the workspace and turn run on, we can kind of see that we've achieved what we want. So models are not generating all the time, but randomly generating every now and again. But the problem is math.random is going to generate a random seed when the client first enters the game. So one client may generate these models where another client may generate a different set of models. So if we want all clients to see the exact same terrain with the exact same models, we cannot use math.random like this, but we can use the random object with a specific seed. So for instance, what I can do is say local random equals random.new, and if all clients use the same seed for this random object, then all clients will generate the same model. So let's say I said x plus z for the seed, so all clients would use this as the seed. And now we can use this random object to get the random value instead. So next number, if we go into workspace and press run, we can see that we're now generating the terrain in a way like this, which doesn't look too random, but now at least all clients will be generating the exact same terrain. One way to improve this is, instead of adding x and z together, would be to multiply x and z together. So let's now multiply, go back, turn run on, and now we can see that the terrain is generating like this. Let me increase the load distance to 8. and we can see we get a result like this. Now this looks a lot better, but we can still kind of see a pattern. We can see that it's mirrored along here, and this left side and the right side are exact copies, but just mirrored, and the same on this side. So this side is mirrored with the right side. So even though this is a lot better than adding the X and Z values, it's still not 100% perfect. So that's why I created the random function. So if we go into our functions, we can see that we have a function here called random, and this takes in a X and Z value and a seed value to generate a random number between 0 and 0.999999. It never actually reaches the value of 1. So instead of using this to generate a random number, we're going to bring in the random function and save it into this random noise function. And I'm going to use this to generate the random value. So random value equals random noise. Now this requires the X and Z and a seed. Now this function likes a very large seed number. So let's pass in a very large number. We can also make it a float, and we can delete these. So now we're going to use my function to generate a random number. Let's go back to baseplate, turn run on, and now we can see it's no longer mirrored, and we can see it looks a lot random. Now we can reduce the frequency of how often parts generate. So what I can do is, instead of having 0.2, reduce this to 0.1. So now it should have a lot less chance to generate. We can further reduce it. So I can go 0.1. And now we can see it generates a lot less models. Another method of generating models is, instead of using random noise, is to use the Perlin noise. So this is the same Perlin noise that we used many times before in this video. So let's use this Perlin noise and see what this looks like. So I'm going to comment out random noise. And if we remember, this requires the X, Z, the seed. So let's do a seed of 1, 2, 3, 4, 1, 2, 3, 4. And then it requires, if we double check, the scale and magnitude. So let's set the scale to 0.01 and a magnitude. Well, the magnitude doesn't really matter because we're only checking to see if it's between 0.01. So let's just do a magnitude of 1. Now, this is not going to give the same ratio as before because remember, Perlin noise goes from -1 all the way to +1. So we should reduce this to something like -0.2. And if we come back and turn run on, now we can see that Perlin noise allows us to generate models like this. And we could even use Perlin noise and random noise together. So once we've determined that the Perlin noise is allowed to generate a model here, we could put another if here. So we can do random value 2 equals, and let's use this random noise for the next layer of randomness. And we could say if random value 2 is less than 0.2, then we spawn the model. So first we're going to use Perlin noise, and if Perlin noise is less than 0.2, then we can go into here, and then we're going to use random noise, and if random noise is less than 0.2, then we're going to finally clone the model. So if we go back, turn run, we can see the Perlin noise, and we can see the random noise within the Perlin noise. And if we wanted it to be more rare within the Perlin noise, we could simply change this to a smaller value, for instance 0.05, and turn run on. And now the chance of the noise is a lot more rare within the Perlin noise. Currently, we are doing all this work inside of the synchronized function. And this function does not run in parallel. So if you remember from the start of this video, I said it's better to run the work inside of the parallel section, and desynchronized runs in parallel. So it would be better to do all this math in this function. So let's try to move as much work from the synchronized function to the desynchronized function. So what I'm going to do over here, I'm going to copy and paste all this over here. And the only thing we can't do is clone, pivot, and set the parent of the clone. So let's move this over to here. And then over here, I'm going to set a value inside of the data table to indicate to the synchronized function that it's okay to use a model. So what I'm going to do is say data.model equals, and I'm going to pass model1. So we're going to tell the synchronize function to use model1. So let's set model1. I'm also going to set the C frame over here. So let's say data.cFrame equals, and I'm going to move this C frame from here to here. And now on this side, I'm going to check to see if this model has been set. So I'm going to say if data.model equals nil, then return. And if it doesn't equal nil, then we're going to clone the data.model, and we're going to use the data.cFrame to pivot the model. And now that we've moved all the operations to the desynchronized function, let's test it to make sure it's working, and we can see it's still working just like before. And if we wanted to, we could set this data model variable to model2 to spawn the blue models. So what I can do is say else if, and say if random value, and if we remember, Perlin Noise goes from -1 to +1. So I'm going to do it on the other side of this noise. So more than 0.2, then, and then I can do this random noise again. So let's copy and paste all of this into here. So if this noise is less than 0.05, I can set this to model2. And now if we test, we should see that model1 gets spawned on this side of the Perlin noise, and model2 gets spawned on this side of the Perlin noise. In this video, we've mainly been using Infinite Scripter to generate terrain, but technically, Infinite Scripter has nothing to do with terrain. All it does is load your modules and runs your modules. So while we've been using it for terrain, it's not limited to terrain. We could use it to do things like generate clouds, generate NPCs, or anything you want, and all you have to do is script it within your own modules. So before I end the video, let me just quickly show you some presets that I've created. And while these presets don't show the full capabilities of this plugin, it may give you some examples of the kinds of things you can achieve. So let's take a quick look at 3D terrain. And if we turn run on, we can see that we generate terrain, but this terrain uses 3D Perlin noise in order to generate cliffs and like holes. So if we walk around, we should see things like this with little holes that we can walk through. And we can also take a look at the triangles preset. And if I turn run on, we can see that this one uses triangles in order to generate a terrain. And this also has 3 modules. And if we look at the data module, which is the only one you're required to understand, we can see that all we have to do is set the position and set the color. And finally, let's take a look at the models preset inside of the others group. And what this preset does is if we turn run on, it will spawn models randomly around the world. And the way this works is if we look at the chunks module, it uses a raycast, and then it uses the raycast results in order to calculate the model's C frame. So what I could do is duplicate the base plate. And if I change the size to something like 512 by 512 by 512, and if I move this over to, let's say over here, and if I rotate this to something like this, and now if I start spawning in models, because we're using raycasts, it will use the parts normal vector to rotate the model so it fits perfectly on the surface. If you need help with anything, you can join our Discord server in the description of this video. And once you join the server, you can come to the help forum and create a new post and ask any question you like, and we'll do our best to try and help you. Thank you for watching my video, and if you have any questions, feel free to leave a comment down below.